Today we're going to build a local AI agent in Python. What does that mean? An AI agent is a system that can complete a task autonomously, even if that task involves multiple steps. For example, if I have a mail assistant, an ordinary LLM could do basic tool calling and list all my unread emails or summarize an individual mail, but an AI agent would be able to list all the emails, select the ones I'm interested in, summarize them, and export this summary as a PDF document. In a nutshell, I can give it a task, it can think about that task, and then it can execute multiple steps using multiple tools dynamically to solve that task. And this is what we're going to build in this video today locally on our system, using Python, LangChain, LangGraph, and Ollama for local models. So let us get right into it. So we're going to learn quite a lot in this video today. We're going to build our own custom local AI agent in Python using LangChain, using LangGraph, and using Ollama. And the only thing that you need to follow along with this is a GPU that has sufficient VRAM to run a somewhat capable model at least. In my case here, this is the NVIDIA GeForce RTX 3060 Ti with 8 GB of VRAM. And this is enough to run, in my case here, Qwen 3 with 8 billion parameters, but you can also pick a smaller model. That shouldn't be too much of a problem. Speaking of GPUs, I have something interesting to tell you. I am going to attend the GTC that is coming to Paris in 3 weeks, so the NVIDIA GTC in Paris, which is an event that you definitely don't want to miss if you're someone interested in machine learning and or GPUs. NVIDIA's CEO Jensen Huang is going to hold a keynote on June 11th there, and also besides that you're going to see many events, many sessions, many talks from various companies like Siemens, Mistral, BMW, DeepL, and many more. And you will also have wonderful learning opportunities because NVIDIA offers their full-day workshops at the event for a reduced price. But the best thing is, if you register for the event using the link that you will find in the description down below, you will be able to participate in a raffle where you can win an RTX 5090 signed by NVIDIA's CEO Jensen Huang. As I said, I'm going to be attending the event and I would be happy to see some of you guys there, but now let us get back to the tutorial. Alright, now let me briefly show you what we're going to end up with here as a motivational preview up front. This is what we're going to build today, an AI agent running on our own hardware, so this is not related in any way to OpenAI, Google, Mistral, Anthropic. We have no API keys here. All of this is running on Ollama, on my own hardware, on my own GPU, and I can have a basic conversation with this agent like with any other LLM, so I can say, hey, how are you? And this LLM or this agent also has access to certain tools. In this case, 2 tools. One is the list unread emails tool and the other one is the summarize email tool. So just 2 tools in this case to keep it simple. And what makes this an agent is of course not just tool calling, because tool calling is what most LLMs can do nowadays, but this agent can combine tool use. So what it can do is it can not just list all the unread emails, it can not just summarize an individual email, it can also do something like summarizing emails after looking at what emails are unread based on certain criteria. So let me show you a simple tool use call. I can say list all my unread emails. And the cool thing about this is I have a mailbox here where I have 3 unread emails, 2 from Florian, 1 from Mike. All 3 are from me, but we have different content. Here we have a to-do list, here we have a deadline, and here we have a reminder for a birthday. And what it does here now is it looks at all these and it gives me the information. We have a reasoning process here, and the output is this. We have these 3 unread emails, but now I can do something like list all of my, or let's do it differently. Let's say summarize all unread emails that are from Florian. So what it has to do in this case, since this is just a function that summarizes an individual email, is it has to look up the UIDs for the emails coming from Florian, and it has to summarize them and give me the summary. So I can say also, since the model is not the smartest one, it's just Qwen 3 with 8 billion parameters running on my limited hardware. The more intelligent the model that you use, the more capable your agent is going to be. But since I'm using a quite small model, I need to be a little bit more explicit when I explain what I want to happen. So I'm going to say summarize all unread emails. For this, look at the unread mails and determine which ones are from Florian. Now I know my camera is blocking this. I'm going to show you that in a second. And I'm going to say here, then summarize each of those. So when it gives me an answer, I'm going to move my camera, or I'm going to just press enter a couple of times so we can see this. But what you can see now, it doesn't have to retrieve the unread mails anymore, but you can see it did 2 tool calls, not just an individual. It summarized the email on 3 and 4. This is just the ID for this and this email here. Now it summarizes everything, and it's going to tell me what it's about. There should be information about this to do and information about a birthday, I think. And now we can see here, Florian's birthday is on January 7th. Now, there isn't a summary. Is this the full summary? What about the other mail? Give me the full summary. Again, this is probably the limitation of the model here. But essentially, the idea is we can build an AI agent that can use multiple tools together, not just individual tool calls, not just, hey, I'm going to give you either a text response or I'm going to call one tool and give you a response. Here, what we can do is we can call tools, get a response, evaluate, call another tool, evaluate the response again. And all of this is based on a graph. So you can see now it didn't call any additional tools. It said now here, summary of reminder, birthday is on January 7th, and then here's summary of to-dos, code AI agent, go to gym, read 20 pages. This is actually true. Now, let me briefly just show you that all of this works also from first try and from scratch. So I can do something like list all my unread emails right in the beginning. And if any of them are from Florian, summarize each of them and give me the output. So that should now call all the tools in a row, because in my email mailbox, I have 2 emails from myself. So it should find them and it should give me the summary. There you go. List unread emails tool called, summarize email tool called on 3 and on 4. So it listed the emails, doesn't have to show them to me. Internally, it saw them. It now summarizes the tool called on 3, summarizes it on 4. And in the end, I'm going to get the aggregated summary of both emails. There you go. I get these unread emails. Interestingly, it also included the one I'm not asking for. So it said here, MikeNeural9.com, no summary needed, not from Florian. Okay, maybe you can also just not write it then. But in this case, we get here summary, reminder, Florian's birthday is on January 7th, and to do code AI agent, go to gym, read 20 pages. So this is what we're going to do. So let us now get started with the setup. We're going to build this mail assistant AI agent that I showed you here. And of course, you can customize it. You can add more tools. You can use a more capable model. All of this is going to make it more interesting. What I want to do in this video is I want to give you the tools, and then you can use them and you can extend this however you want. I want to show you the principles, and then you can practice yourself. So we're going to start by opening up a terminal and navigating to a directory where we want to be working in. In my case, it's going to be the current directory. So here I have this empty directory current. And what we want to do now first is we want to install all the dependencies. We want to install all the packages that we're going to need in this video today. As I said, we're not going to need any API keys. We're not going to connect to any external APIs for large language models. All of this will be running locally on our system. Now, when it comes to installing packages, you have 2 choices. You can go the old school way and just say pip or pip3 install, and you can install all the packages. This is going to work perfectly fine. If you're comfortable with that, go with that. No need to change anything. It's going to work perfectly fine. But nowadays, the modern way to do that is to use UV, which is much faster. It's a Rust-based package manager. I have a video on it also on the channel. And basically what you do is you create a UV project. Project is a fancy way of saying it creates a couple of files in your directory, and then you use UV add instead of pip or pip3 install. So if you don't want to learn anything new here, you can just go with pip3 install and then the packages. But I'm going to use UV just because it's faster. So I'm going to say here UV init. If you also want to use UV, you can say pip or pip3 install UV, and then you can just use UV as a CLI tool. So UV init is going to create the project in this directory now. You can see here we have a main py file, we have a pipe project toml file, and a README. In addition to that, we also have some stuff like a Git repository. You don't have to care about any of that. All you need to know is that you can now add packages with UV add. So you can say UV add or pip3 install. And now we're going to add the packages LangChain. We're going to add LangChain -Ollama. We're going to add LangGraph. And we're going to also add Python imap-.env, not for API keys, but we are going to connect to mailing servers, so we're going to need that. And also imap-client for the same reason. We're going to connect to mailing servers. So I'm going to talk about this here in a second. But these are our dependencies, so I can just run this now, and you can see it's done. That's why we use UV, because it's that fast, especially because these packages are already cached. And now we can go into the code and we can delete everything that's there by default. So we're going to start with an empty file. And before we go into the coding, two things need to be set up for this to work if you want to do the exact same project here. One is you need to have Ollama on your system so that you can actually have your own large language model on your own hardware. In addition to that, you also want to have a mailbox. This can be your private mailbox. You don't need to have a corporate account or anything. You can have a Gmail. You can have whatever you want. The important thing is you need to know a couple of things about your mail provider, about your account, which are very easy to get. You need a couple of things. These are, first of all, the IMAP host, so the IMAP server. This is something like mail.whatever.com. The best way to find out what your provider is or what your IMAP host is you type something like Gmail IMAP server, or you type something like whatever provider you have, provider IMAP server. And what you're going to get is some host that you can use. In my case now, since I'm using Hetzner here, my host is, for example, mail.your-server.de. This is just the Hetzner IMAP server. And then you need two more things, which you probably know. The one is your email. In my case now, this is tutorial@neural9.com. And the third thing is your password. You need to know also the credentials. So whatever your password is, this is your password. You need to know these three things, and this is what we're going to use to connect to the mailbox. There are some things that can differ. For example, we need to select also a directory or a folder to start with. In most cases, that's going to be inbox. However, if you have a German, French, or whatever language provider, maybe it's called different. Some providers rename this, so make sure that you know how to connect to your specific mailing instance, and also make sure you have Ollama installed. How do you do that? You go to ollama.com, you go to download, and either for Mac, Linux, or Windows, you use the respective version, and then you have it on your system. And then you want to do the following. You want to go to the models, and you want to find a model that you can use that is decent in terms of capability, but still fits also into your hardware. And the best way to figure that out is to try or to Google. So in my case, what I did is I went with Qwen 3 and with the default with the 8 billion parameter version. Now, if you have less VRAM, you can go with a 4 billion parameter or with a 1.7 billion parameter. If you have more VRAM, you can go with a 14 billion parameter. The problem is the less parameters or the fewer parameters you have, the stupider the model is, and maybe it's not going to recognize that it has to call certain tools. So yeah, it's a trade-off. You need to find something that runs on your hardware and still performs at least somewhat decently. But once you have chosen your model, you need to know what this string is. In my case, it's Qwen 3 8b, or since it's the default, it's just Qwen 3. But in my case here, I can go and say Ollama list, and I have this model on my system among other models here, but this is the model that I'm talking about. And if you want to get a model onto your system, what you need to do is you need to say Ollama pull and the model identifier. So Qwen 3 8 billion. If I didn't have it on my system now, when I run this, it's going to download it, then it's available. And Ollama, of course, needs to be running. If it's not running on your system, you need to do Ollama serve. This is going to run the Ollama instance, and then you can just connect to it in Python. That's the only thing that you need. You need a mail account and you need Ollama set up on your system, and then we can get started with the code after we installed all the packages, which we already did. And maybe one more thing before we write Python code, we need to create a file called .env. And the .env file usually contains API keys, but since we're not using APIs in this case, we're only going to have our mail information in here. So we're going to say .env, then we're going to open it up and we're going to say imap_host is equal to whatever the host is. In my case, as I said, mail.your-server.de, then imap user is going to be equal to tutorial@neural9.com, and then imap_password. In this case, now I'm not going to type it on screen, but here you put your password, whatever it is, and then you just save and close the file. So now we're done with the setup. Let us get started with the interesting part, which is the Python code. And we're going to start by importing a couple of modules and packages. So first of all, OS to get environment variables, then also JSON for some JSON input that we're going to feed into the model, or output that's going to be fed into the next tool. And then also from typing, we want to import typed dictionary, so type dict. Then we're going to use .env or python.env to load the environment variables that we just created in the .env file. So I'm going to say here from .env import load.env. And in addition to that, we're also going to say from IMAP tools import mailbox and. So and with capital letters, basically something that we're going to use to combine conditions with a logical and mailbox is just an easy way to connect to our mailbox without having to use the IMAP package or the IMAP lib package from Python. And now we get to the interesting part, which is LangChain and LangGraph. Here we're going to say from langchain.chat_models, we're going to import the function init chat model. This is going to create our Ollama chat instance. Then we're going to say from langchain_core.tools, we want to import tool, and this is a decorator. So this is something that we're going to put over functions, above functions, to make these functions tools. And the description of these tools is going to be in the doc string. So we're going to document our functions, and the large language model would then know what the tools are about. So this is a decorator that we need. And then from LangGraph, we're going to import from langgraph.prebuild the tool node. I'm going to explain nodes and edges when we get to it. And then from LangGraph, where is it? .graph, we're going to import the state graph, the start constant, and the end constant. Again, I'm going to explain these things when we get to them, but I want to start with a basic setup. We're going to write a basic function to connect to our mailbox. Then we're going to provide these two tools, which are listing the unread emails and summarizing individual emails. And then we're going to build the whole graph and the whole agentic stuff around it. So let us get started by calling the load.env function so that we get our environment variables. And then let's load our constants. So IMAP host is going to be equal to OS get environment. The reason we're using the .env file and not just directly putting this here as a string is for security reasons. Of course, for the tutorial, it doesn't matter, so we don't have to do it. But it is a good practice to have the important things or the sensitive things in the environment and not in the code. So we're going to say here IMAP host is equal to OS get env IMAP host. Then I'm going to copy paste this. IMAP user is going to be equal to IMAP user. And same thing with the password here. IMAP password is going to be equal to IMAP password from the environment. And then the IMAP folder is going to be, as I said, inbox in my case. If this doesn't work for you, you have to figure out what the name of your inbox is in your provider, maybe what it's named in your interface, maybe something completely different. You have to figure that out, but most of the time it's going to be inbox. And what we also need to define here is the model that we want to use. So I'm going to call this here chat_model. And in my case, as I said, this is going to be Qwen 3 and 8 billion parameters. The reason you need to specify it here again is because, of course, you can have multiple Ollama models. Again, if I do Ollama list, I have a bunch of them. And to know that I actually want to target this one, I need to provide it here as well. So I store this as a constant. I can easily exchange that later on. And now we can define the method for connecting to our email and also the state that is going to be used in our graph. So LangGraph works with a state that is passed from node to node. And this state in the simplest way, or in the simplest case, just contains the message history. But of course, you can add more stuff to that state if you want to. But we're going to keep it simple. We're going to start by saying class and then chat state. This is going to be a typed dictionary. And we're going to say here that it just contains messages, which is a list. This is the most basic state that we can have. But of course, you can add some more context here and some buffers and whatever you want to use. But to keep it very simple, we're just going to keep track of the messages. And what we can do now is we can say def connect. This is going to be our function that connects to the mailbox. We're going to say here mailbox is equal to mailbox for the IMAP host, and we're going to log in. So we're going to say mailbox dot login, and then IMAP user, IMAP password, and then initial folder is going to be equal to IMAP folder. So that is that. And of course, we need to return the mailbox object. And this is why we use this package. This is why we use IMAP tools and not IMAP-lib. It's very simple. We just define the host, we pass username, password, and folder, and it's done. We're done. We can just use this now, and we can use the various functions from it. So now we need to define our tools. And a tool is basically just a function that can be called by the large language model, by the agent. So we're going to define a function called list unread emails. And this is not going to take any parameters, but we need to describe it. So we're going to add a docstring, which is 3 quotation marks here, 3 opening and 3 closing quotation marks. And in this text, this is now not just a comment, this is not just documentation, this is going to be accessed by the agent, so it understands what this function is about. And we're going to say here, return a bullet list of every unread message or messages, subject, date, and sender. Or maybe also let's add here UID, because that's going to be important for the summarization. So that is what this function does. Now, of course, we need to also implement that. So I like to have a message here as an information that this is actually being called, so I know what's happening. List unread emails tool called, just so we know what's happening here. And of course, in production, if you actually deploy this, you want to remove this, but this is just for you to know what's happening. And now we're going to say with connect to the mailbox as MB, we're going to do unread is equal to list, and we're going to use the fetch function. So mb.fetch. Criteria for the fetching is and. In this case, we only have a single parameter, but we're still going to use and. Seen is equal to false. So we want to have all the mails where the seen attribute is false, so where they're not seen yet, so unread. And we want to say headers only equals true, because we are not interested in the content. We only want to see subject, date, and sender. And then we're also going to say mark underscore seen is equal to false, so that we don't actually make or mark the email as read just because we fetched it with our agent. So we need to set this to false, otherwise it's going to read the email, and that's not good. So now close this here. And then we're going to say if not unread, which basically means we don't have any unread emails. Then we're going to say return you have no unread messages. Otherwise, what we're going to do is we're going to say response is equal to JSON dump S. So we're going to take a dictionary comprehension here, or actually it's going to be a list comprehension full of dictionaries. And in here, we're going to have all the mail objects with UID, subject, sender, and so on. And we're going to say here, dictionary that contains the following fields. UID is going to be mail.uid. Then the subject is going to be mail.subject. Then maybe before that here, let's say date is going to be equal to mail.date.as time zone dot string format time. And now we're going to specify the format, which is going to be year followed by month followed by day, and then also hour :minute. So that is the date. We add a comma here. We make sure this is indented properly. And then finally we say from is equal to, or actually let's call this sender, makes more sense. Sender is equal to mail.from underscore. Underscore because from is a Python keyword, so we don't want to call it that. So we say mail.from underscore. For mail in unread. So we do this. We create such a dictionary and add it to the list for every single mail that is unread. And then we have a response, which is a JSON object dumped into a string. So we just have a string essentially, and that is what we return from this tool call. And to make this a tool now, we need to also annotate it. We need to say add tool. So that makes it a tool. And of course, we need to add it also to the workflow and everything, to the graph. But for now, this is a tool. And now we're going to write the second one. The second one is summarize an individual email given a UID. So we're going to take a UID as input, and this is going to be summarized by the LLM. So what I'm going to do here is I'm going to say summarize one email, or let's say summarize an email like this, given its IMAP UID. Return a short summary of the email's content / body in plain text. Just be explicit here. All right, so we have this documentation. Then we're going to do again summarize email tool called, so we know what's happening. Maybe also on and then UID, just so we know what it's called on. And then we're going to say here with connect as MB, we're going to get all the emails. So we're going to say mail is equal to next MB fetch. So this is going to be a generator, which is why we call next. And the criteria is going to be UID is equal to UID. And then we also say mark seen is equal to false. And then we're going to say none in case there is nothing here. The basic idea is we say go to the mailbox and find the email with a specific UID. Now we can take this from this response. This is why it's a chain, or this is why it's an agentic thing, because the user is not going to provide the UID. The goal is to summarize something that we get from this function here. And we connecting, we get the email with the respective UID. We can only do this for a single one. Maybe I should say summarize a single email given its IMAP UID. And then we get the email. If we don't have an email here, we're going to say that it was not possible to summarize it. Could not summarize email with UID. Maybe let's make this a formatted string. So let's say here F and then UID. And otherwise, if there is no problem, if we actually have a mail, we are now going to do a prompt call to a large language model. Now, we're not going to do the call yet because we don't have an instance yet, but we're going to say here prompt is equal to, and we're going to do this across multiple lines. So I'm going to use here parentheses. We're going to say summarize this email for, or concisely. Let's do it like this. Summarize this email concisely, then add 2 line breaks, and now say F formatted string subject is equal to, actually I think, no, we don't need a comma here, so this should work. Subject is mail dot subject. Now we can copy this. We can say from is from, or maybe I should say sender. And then here the date is mail dot date. And then we're going to say that the content, this is important. And of course, we need to add here \n everywhere so that we have line breaks here. Maybe let's add 2. And we're going to say here mail.text or mail.html, whatever. And that is going to be our prompt. So this is not what we return. This is what we feed into an LLM. So I'm going to say here a comment to do. Feed this into an LLM and return the result. But for now, we're just going to return an empty string. And of course, this is a tool. So we need to annotate it with add tool. This makes it a tool. And now we get to the agentic stuff. This is now very basic. We have 2 tools. This is not a video about tool calling. We already know how this works for the most part. We want to know how can I now turn this into an agentic system or into an agent. And how we can do this is we can first of all define the LLM that all of this is going to be based on. So we're going to say here LLM is equal to initialized chat model. So init chat model, we pass the identifier, so the Quen3 8 billion, and we say model underscore provider is equal to Ollama. Now, if you were to use something like OpenAI, you would have to say here is OpenAI and then some other keywords, or something like Anthropic or something like Mistral AI and so on. But we're going to use Ollama, which is going to allow us to use our local model. And then what we need to do is we need to allow this model to use tools. So we need to say LLM is equal to LLM.bind underscore tools. And we're going to send here, or we're going to pass here a list of tools, which are going to be in this case, list unread emails and summarize email. So these are the two tools that the model can use. And now in addition to that, for reasons I'm going to explain when we get to the graph, we're also going to create a raw LLM. And the reason we do that is because we want to have a model that does not have access to tools that we can use, not for the user queries, but for example, for tasks like summarizing an email. We don't want to have an agentic AI in here to summarize this email. We want to have it only to decide what to do next. But for basic stuff like summarizing an email in the function itself, we don't want to use the same LLM. So we can actually just copy this and we can say raw LLM is equal to that. Now, I think what also should be possible, I'm not sure about that, is if we say raw LLM is equal and then we say LLM is equal to raw LLM bind tools. I'm not sure if that works. Maybe you could try it. I think that it will have the same effect, but I don't want this to break my code. So I'm going to do it like this. We have an LLM with the tools and the same model, but without the tools for summarizing. And now actually we can go back into the function here. We can remove the to do and we can say return raw LLM dot invoke prompt. And as a result, we get the content. That is how we do this. So we let the raw LLM without access to any tool summarize the email that we retrieved here in this function. And this is the LLM that we use for the agent itself. So now we need to set up our graph for LangGraph, our nodes and edges and our routers and conditions. And this is where it gets very interesting. And for this, I want to take a little bit of time, not too much. I want to keep this short, but I want to briefly explain to you on a visual level how this works. So what makes this an agentic system is that we don't just have tool use, but we have an underlying graph representing the workflow of the agent. So we have a starting state, and then we have nodes and edges that represent what this agent can do. A little bit like a non-deterministic finite automaton, but much more flexible because the agent has intelligence and storage and can make decisions and so on. But the basic idea is we have a starting point and then we have a node, for example. This node could be an LLM node where the LLM can just take text and produce a response, and this can also call tools. And what can happen now is that this LLM can get to a so-called router, to a conditional edge, if we want to call it that. Let's call this R. And depending on what this LLM does, this router can lead to end, or it can lead to calling a tool. So we could have another node here, a tool node. And in this tool, we have all the different tools that we can choose from. And at the end of a tool call, we get back to the LLM. So the basic idea is if I ask something like, hello, how are you? What it's going to do is it's going to take that, it's going to produce a response, and it's going to just end. Hey, I'm fine. How are you? How can I help you? Something like this. But if I say, please list all of my unread emails, what it's going to do is it's going to go here. It's going to recognize, oh, I have a tool for that. I'm going to call this. This is the response. So now what I can do is I can get this output from the tool and I can go back here and I can now say to the user, these are your unread emails. So again, the process is we go in, we recognize that a tool call is necessary. We go down to the tool call produces the output, the JSON object of the unread emails. This is not what the user gets. This is what the LLM returns, or what is returned to the LLM by the tool. And the LLM can see that and say, okay, now I have the information. I can answer the user query, go next step. This time I don't need to call another tool, so just output the result to the user. This is if I just ask for a list of the unread emails. However, if I say list all my unread emails and then summarize them, or summarize multiple of them, what it's going to do is it's going to start here. It's going to recognize that there's a prompt. It's going to produce an output, and it's going to call a tool, which is going to be list the unread emails. It's going to get that list as a response. It's going to have still the context, what was the user's question if the model is intelligent enough, and it's going to say, okay, he wanted to not only get a list of all the unread emails, he wanted me to summarize all of them if they are from the user Florian, for example. So what it does is it now has this context. It's managed here in the state. So we have the state with the message history. And this state can be more complex, as I said. But now it knows, okay, I need to do another tool call. So I need to summarize the mail with the UID 3, for example. So here's the summary. Okay, I have this now in the message history as well. But I also need to summarize the email with the UID 4. So go back, tool call, go back. And now I have all the emails that I need. So now I can respond to the user. So now I can give an answer to the user. That is the basic idea of a graph. And this is a very simple graph. Today, we're not going to build a very complicated agent, but that is what you can do with LangGraph. And you can scale this. You can have conditions. You can have complicated structures, but this is what LangGraph does. And this is what an agent does with the whole workflow. So we're going to define the LM node as a function. We're going to say LM node given a state. We always pass the state. So as I said, this is a little bit like an automaton. You have a state, you modify the state, you jump to another node. And what we do in the LM node is we say the response is equal to LM invoke state and messages. So it's going to just get the message history and the LM has to respond based on that. So we're going to return, as a result of the LM, we're going to return a dictionary, which is going to be messages, and it's going to be just state messages plus the response as a list or in a list. So what you can see here, even though we don't have type hinting, what happens here is we get a type dictionary, or to be precise, we get the chat state as input, and we also output the chat state. So this node takes the state as input and outputs an altered state to the next node. That is what it does. Then we're also going to define a router. The router is also going to take the state as input, and it's going to route conditionally to different nodes. So we're going to say here, last message is equal to state, and then message -1, so the last message, and then we're going to say return the string tools. If get attribute, we use get attribute, so we have a basic fallback value, but we get the last message and we say, does it have tool calls in it? So is tool calls part of that message? So were tools called essentially? If we have a problem, we just fall back to none. And if that's not the case, what we do is we say end. So basically the router is what I showed you in the graph, this conditional point where we can say, okay, either call a tool again or end. So when you produce a response, either you end and show it to the user or you use it as a tool call. This is what the router does. This is a condition essentially. And now we can define the nodes and edges. We can say tool_node is equal to tool node. Remember, we imported this class in the beginning. And here again, we also pass the list of tools. So list unread emails and summarize email here as tools. And now we can define a builder. The builder is equal to state graph. The state graph is the thing that I showed you here in my paint, the visualization essentially. We have this graph, this automaton, if you want to call it that, and it starts with a chat state, which is going to be just an empty list, no messages yet. And we're going to now say builder.add node, and we can create the first node, which is the LLM. So the LLM node, which is our function here for just taking the message history and invoking a response, or invoking the model, producing a response. Then we're going to say builder.add_node, and we're going to say tools are going to be pointing to tool node. So here we have this tool node that I showed you in my paint. And now we're going to say builder add_edge, and edge is the connection. So again, everything we do here is what I showed you in MyPaint. We have the start state, which we're going to add here in a second. We have the start state, we have the LLM node, we have the tool node, and we have the conditional router. So we're going to say now here, the first edge is from the start state to the LLM state. So from start to LLM. This means that we start a process, we go to LLM, we get a completion. Then we also want to have a connection from tools to LLM, because once we're done with a tools call, we also want to be able, we also need to go back to the LLM. So the LLM needs to process the output from the tool. The tool itself cannot end the process. The tool has to take its output, show it to the LLM, and then we can decide what we want to end or not end in this process, or whether we want to end. And then we need to also say here, add conditional edge, and this is going to be from LLM to the router. And the router is going to have the possibility to either go to tools or to end. In the case of tools, if the router returns tools, that means that we're going to go to tools, so to the tools node up here that we defined. Otherwise, we're going to go to end. So if we get end, we're going to go to the constant end. All of this stuff that we imported, start, end, and state graph, we imported these in the beginning up here from LangGraph. So again, this is exactly, if you think about it, this is exactly what I sketched in MyPaint. We had the start going to LLM, LLM going to a router, going to either tools or end, and tools going to LLM. This is exactly what I showed you. And now we can compile that. We can say the graph is equal to builder.compile. And finally, we can now use all of that. So now we can go and say if __ name __ is equal to __ main __. Then we want to have our loop. We want to say start with an empty state. So state is equal to a dictionary where we have messages starting as an empty list. And then we can have a simple prompt here. We can say type an instruction or quit, for example, also with a line break in the end. And then we can say while true, endless loop essentially, user message is equal to input, and we want to have some character here like an angle bracket, a closing angle bracket, maybe with a space afterwards. And then if the user message lower is equal to quit, then we want to break the loop. So there should be a keyword that allows us to break. And otherwise, we want to use our agent. So we want to say state, message, append, and we're going to append a dictionary with role, user, and content, user, message. And now we need to use the graph to proceed to go to the next step. So we're going to say state is equal to graph.invoke state. And finally, we get state messages -1 dot content. So the last message of the history. In order to run this, if you also used UV, you now need to say UV run main.py. If you didn't use UV, you just say Python or Python 3 main.py. So depending on your setup, UV run main.py. Let's see if this works. Of course not, because I'm assigning in an if statement. This is not very intelligent. We need 2 equal signs here. Let's see. UV run. Of course, I also have no module IMAP tools. Why is that? Didn't I add it? UV add IMAP tools. No, I didn't add it. Okay. Main.py. Then we have add conditional edges. Oh yeah, sorry, this is plural because we're of course adding multiple edges, not just one. So we need to say here edges, plural. And then we can try to say something like, hey. Of course, it doesn't work because we have messages, not message. These are the small bugs that you make when you record. So let's try again. Maybe let's just clear this one more time so you have the text up there. Now I'm going to say, hey. Let's see if I get a response. No, I don't, because I have a problem one more time that I used message instead of messages. So where is message? Message, there you go, here. Not very intelligent. Let's do clear again, UV run. Hey, and now hopefully, there you go. How can I assist you today? It also informs me about the tools available here, and now I can do something like list all of my unread emails. So that is just a simple tool use call, but now we can also try to combine it. It's easier for the model if I first try to ask it for the emails, I think, but it also works if I do it combined from the very beginning. The problem is, again, the model I'm using here is not very capable. If I was using like GPT-4o or Gemini 2.0 Flash, it would be like super easy. But in this case here, if I want to combine something, I need to make it a little bit more fancy. So I can say something like summarize the content of all emails from Florian. So hopefully it can realize now we have UID 3 and 4. There you go. It recognized that these are from Florian. It called the tool 2 times, which is not possible without an agent because you cannot call the tool twice, because what happens in an ordinary LLM is it calls the tool and returns. It doesn't call it again. It doesn't have this conditional edge. But you can see the problem that I talked about here just summarizes the last one. This is just the summary of the last one. Please provide all summaries. So it doesn't have to call again, but in this case now it fails. This doesn't make a lot of sense. All right, so I found a little issue in our code here, which is that the tool node always returns a blank new message history. So what we need to do here is we need to actually wrap it into a function. Let's call it tools node. And what we're going to do here is we're going to say state is the input, and we're going to append whatever the tool node creates and not just overwrite the entire message history. So we're going to say here result is equal to tool node dot invoke state. And instead of just overwriting this, we're going to say now return dictionary where messages is the state messages plus whatever we get as a response here. So plus result, and actually result messages. Because I think that this, unlike the LLM response here, this is going to have its own message history. So we need to just concatenate them together or join them together, whatever. And here now we're going to say tools node, plural. And that should now lead to a much better performance. So I'm now going to say uv run main.py, and now I'm going to say list all unread emails if there is any, or if there are any emails from Mike, summarize them, take their UID from the output to be a little bit explicit here with the small model. And then we're going to say take that, summarize them, and give me the summary. Again, if the model is more intelligent, no need to do that. It's going to figure that out on its own. But in this case now, we have to be a little bit more explicit with the 8 billion parameter model. List unread emails tool called, and now hopefully summarize email tool called on 5. Perfect. So it should give us the response, and project XYZ's deadline is this Friday, sender mike@neural9.com. Okay, so let's try something else. Let's quit. Let's start this again, and let's see if we can do that with multiple emails. Let's say list all my unread emails, look at them. If there are any emails from Florian, summarize them, and give me the output. Let's see if I don't mention UIDs, if it's going to work or not. And maybe, there you go. Summarize email tool called on 3 and 4. I think I'm still going to just get the 4 because we don't have this aggregation, this collecting tool. Probably I'm just going to get the output for 4, but maybe not. Let's see. Maybe I'm going to get a full summary because I now have the full history. Maybe that was the problem, but I wouldn't be surprised. Oh, there you go. Okay. Actually, here are the summaries of unread emails from Florian, UID3, UID4. Actually, maybe you want to hide that from the user. Reminder about your birthday on January 7th, and to-dos code AI agent go to gym, read 20 pages. So actually, by doing it like this, we solve the problem. We can just do it like this. So that's it for this video today. I hope you enjoyed it and hope you learned something. If you want to see more agentic AI content, agentic systems, AI agents, OpenAI and LangChain and Crew AI and LangGraph and all these different packages, let me know in the comment section down below. Let me know by hitting a like button. Let me know by subscribing. And also, again, don't forget what I mentioned in the beginning. I'm going to be attending NVIDIA GTC. And I think it's a very cool event if you're in Europe especially. So make sure to check it out. And other than that, thank you much for watching. See you in the next video and bye.